Hello everyone, my name's Jamil and this is my video for the major project for the EECS 1011 course. I have decided to create an automatic door with a back sensor to help avoid theft. Well, let's start by explaining why did I choose this specific topic. Well, I chose this topic because according to an article published by safety.com, 2.5 million burglaries occur per year, and that's according to American statistics. And also, homes without security system have 300% more chance of getting broken into. So, which means that people need to further advance their security systems in their homes. Well, now let's explain the main entry points for burglars to enter the targeted house. Well, the main entry points are the front doors, back doors, garage, ground floor windows, according to an image published by Blake Security, which is located in the UK. I have decided to further enhance the security at the front and back doors of a building or a house. Now, let's explain how I initially started the idea. The first step I took towards accomplishing my targeted project is that I drew a systematic diagram. As you can see, two PIR sensors and a motor which is connected to a door, and they're all connected to the Arduino board, and which is connected to a laptop or PC to actually control the Arduino. Now let's go further details of the project and go into the components of the project. Well, as you can see, I used PIR sensors, jumper wires, and a servo motor. And of course, the Arduino board, which is one of the main components of the whole project. And of course, the laptop to control the system. Now, let's go and take a look at the shape of the system. As you can see, this is the front side, and this is a view from the top, and this is the back view. Several test methods were used to end up with a final draft of the code. Mainly, breakpoints were used to identify specific errors when all the codes were combined. Each code was run individually to make sure that there are no individual errors before combining. And after combining the codes, several drafts were made to end up with the final results because some errors showed up when combining the codes together. Let's take a look at the code of the project. First, I've configured each pin to its proper type, input or output, and then I've assigned figures, including an audio, to variables into MATLAB, and then I had two live figures inspired by the lab, and then they're subplotted. I've labeled the x-axis, y-axis, and titled them. I even included the legend, and then I've initiated a while loop that stops only using a button, an LED that goes on for 2 seconds, then goes off after every reading. I've assigned the readings from the inputs into the Arduino into variables, and then if data is being detected from the front sensor, a warning goes on that the door has been opened with a buzzer that goes on for 1.5 seconds. The door moves clockwise, and then it stays there. It stays open for 5 seconds, and then it moves anti-clockwise to shut it back. The reading of the angle of the motor is taken, multiplied by 180 to convert it into degrees, and added to another subplotted figure, and then a picture with an audio goes on for 5 seconds, and then in the end, if the back sensor has less than 1, buzzer goes on with an image goes on for 5 seconds. This is a live graph that was a result of the previous code we've seen, and then in this graph we'll see that the front sensor detects motion, so it sends a low output, which indicates that the door has to open. A text will show up on the live graph indicating that the door has opened, and a drop in the blue line, which is the front data sensor. This is The second scenario, in which the back sensor detects motion, as you can see, there's a drop in the red line, which indicates that the back sensor has sent low output to the Arduino and MATLAB. These are two images that show up as part of the process that they were first assigned into variables into MATLAB. The left figure shows up when the door is open, and the right figure shows up when the back sensor detects some motion and sends a low output into the MATLAB, which means that the back of the building has detected some motion. Now let's take a look at the final result of the whole setup and all of the code working in harmony to produce one final result for the whole project. Hello everyone, this is the final result after combining all the codes and figures together. As you can see, there's a live graph with two subplots. The first graph indicates the voltages / data being recorded from the sensors, from the front and back sensors. The red line indicates the data being recorded from the back sensor, and the blue line indicates the data being recorded from the front sensor. The second subplot indicates the angle of the motor. Now let's test it out. The buzzer goes on. The door opens and stays open for 5 seconds. It then closes.
Welcome.
And an audio with this figure shows up. Now, there's also a text that shows up on the figure, on the live graph. And the drop in the blue line indicates that there's a drop in the voltage of the front sensor. Now let's test the back sensor. The buzzer goes on and stays on for 8 seconds. This figure shows up and stays on for 5 seconds. There's also a text shows up on the live graph, and a drop in the red line indicates that the back sensor has a drop in its output. And as you can see, the LED goes on and off after every single reading taken from both sensors. Now, the only way to stop the whole system is by pressing this button. As you can see, the system now stops. This is the reference list for all the resources used in this video.